In this video, we'll discuss the nomenclature of ketones and aldehydes. So that's a weird looking and sign. So in terms of priority, aldehydes are the highest priority group that we've discussed so far. So an aldehyde is always going to be at the end of the chain by definition if it's in your longest chain because it has that H on the end. So that's our higher priority, followed by ketones, and then alcohols, and then alkenes and alkynes, and then lastly our R or our X groups. So we know how to name for an ene and an ine already. If you have an alcohol that is a substituent, it's called a hydroxy group. And so you would just name that as a hydroxy. So whatever part on the chain it's on, you put a locant number in front of it, and then the word hydroxy, alphabetical order like we've been doing. As a substituent, a ketone is an oxo group. And then we haven't run into a situation yet where we would have an aldehyde as a substituent, but if it was, for when we do this later, it's called a formal group. So if we look at ketones, we'll first look at sort of a simple example. A ketone has to be internal, okay? So I'm going to number to give it the lowest possible locant. So this is going to be 2-heptanone. So this "-one" right here, in place of the E for heptane, tells me that I have a ketone, and the 2 tells me where. So if the ketone is the highest priority group, your end name will end in O-N-E, own. So we'll look at an example of a aldehyde now. So by definition, the aldehyde is going to be terminal. And let's put a ketone on there as well, so we'll have a substituent. The aldehyde is higher priority than the ketone, so it's going to be the number one priority. So I'll start at the end there, 1, 2, 3, 4, 5, and 6. So this is 4-oxo, so that tells me that I have a ketone at the 4 position. And then I don't have to put the 1 because it's terminal, but I can if I want to. But usually you would just say 4-oxo. You could say 1-hexanal. So this Al tells me that I have an aldehyde as my root name. So the other way that we might do this is to just say 4-oxo hexanal. And actually probably you want to go with this way. We used to put in locants for the where it is, even when it was at the 1 position more, but more and more we're just making the assumption that it's at the 1 position if there is no locant provided. And so often when you enter your answers into your homework, it'll take it either way, but usually we write it without the 1 locant. So aldehydes can be coming off of a ring, and for that reason we have a little bit different naming system, and let's put an alcohol on here as well. So we can start wherever we want on a ring. The highest priority group is this formal group right here, so 1, 2, 3, 4, 5. But this is essentially a cyclic aldehyde, and so when that's the case, we call it a carbaldehyde. And that's going to go into the name, so it's only the cyclic ones that we name like this. So this guy is going to be called 3-hydroxy cyclopentane 1 carbaldehyde. So this carbaldehyde tells us that we have a cyclic system with a aldehyde coming off of it. So we have got a cyclopentane ring, that's our main chain essentially, it's a cyclic chain, this ring. We have a hydroxy group coming off as a substituent, and we have this aldehyde coming off of it, and it's the highest priority, so we name it as 1, so we do put in our 1 carbaldehyde. Since it's on a ring, it could be anywhere, so you want to specify that you start from that 1 position. So we'll do one more example where we have a alkene as well. So this, next to the carbonyl group, is the alpha position and then the beta position. So this is called an alpha-beta unsaturated ketone. So that's just kind of the type of functional group it is. So we have this conjugated system right there, and that can influence the reactivity, and we'll see that a little bit later. In terms of naming this guy systematically, let me find a different color. Well, we're going to start with the highest priority group, which is our ketone. So 1, 2, 3, 4, 5, 6. So this is going to be a cyclohex, right? Because we've got 6 carbons here. So this is going to be cyclohex 2-ene 1-one. So both of these change the root name, but the ene part comes before. So 2-ene tells me that I have a double bond beginning at the 2 carbon, so then necessarily stretching to the 3 carbon. And the 1-one, since I'm in a cyclic system, tells me that I have a ketone. And that is my parent chain, and so I start at that highest priority group, the ketone.